Good afternoon, everyone.
Good afternoon.
Yes, good afternoon.
Yes, it's good to see you, our facilitators, Professor Susan Tumwebaze, Dr. Helen Namaweje, and Dr. Thomas Odong. I'm here with you briefly, but my colleagues, Selma and Atu, will be with you throughout this training. So allow me to hand over to Miss Selma to give some welcome remarks on behalf of Forum. Thank you very much. Selma, over to you.
Selma, we're not hearing you.
You're muted.
Please, can you hear me now?
Yes, we can hear you.
Oh, so it's now, please, sorry about that. I think my microphone settings. But if you can hear me now, I just want to welcome you all. Thank you very much for being here with us on this training on statistical modeling. Sorry, Atu?
Can you hear us?
Yes, I can hear you now.
Yeah, but yeah, I mean, in my side, I cannot hear you.
You cannot hear me up to now?
Yes.
How are you responding?
I can hear you.
You are now clear.
Thank you. Okay, thank you very much. Please welcome to this webinar on statistical modeling using R programming language. This is not our first training we are doing, and I want to hope and believe that many of us who are in attendance, you have already attended more than once or probably at least once this type of training. And if not, we do encourage you to still follow our platform on YouTube so that you can catch up with the previous trainings that have been done in this subject area so that we try to accelerate the speed a bit. Still, that should not stop you from participating and asking questions and clarification because we also do not want to leave you behind. So I'd like to just welcome you and greatly thank our facilitators who are always here with us and are always willing to take us through this course as many times as we ask or need. So thank you very much, Professor Susan, Dr. Odong, and Dr. Helen, for being here with us and for taking us through and for always making this subject very easy to understand. So thank you very much and welcome to all our participants. So as always, this is a webinar webinar setup. Please, we request that you use the chats only to engage, especially what you are doing now in terms of greeting and letting us know where you are logging in from. But because of the high traffic in the chats, we request that you use the Q&A for any questions, any clarifications that you may want to with regarding to the course. Please do not use the chats for asking questions, because we might lose your questions that you'll be asking. And then the second thing, if you need to speak, if you are given a chance to speak, first of all, you need to raise your hands. Like I can see already one person or so who have raised up their hands. But when the facilitator allows you to do so, we will unmute you, and we will promote you to be able to unmute. And so you have to unmute your microphone and speak as you are requested by the facilitator. And after you finish, if your query has been responded to or your engagement with the facilitator are completed, you then return back to the main, to the other house or side of the room. So thank you very much, and I do hope that you enjoy the webinar. This webinar is part of our AGM, Annual General Conference, which is going to be in Gaborone in Botswana, December. Thank you very much. Professor Balava, over to you and the team.
Thank you very much, Salma. And I would like to take this opportunity to thank RUFORUM for funding this training and also giving us an opportunity to train. I've already been introduced. I'm Susan Balaba-Tumwebaze, and will be taking you through with my colleagues. I'll give an opportunity to my colleagues to introduce themselves before I give the overview of the training. Over to you, Dr.
Hello. Hello, good afternoon to everyone. I'm happy to be here and conduct this training together with my colleagues. I know there are a number of you probably who attended our training before. We're happy to again have you with us. As the days will progress, you get to interact more and get to appreciate what we have to offer. So I'm a biometrician based at Makerere University, like my colleagues. So for now, I think my introduction can stop here. Thank you.
Go ahead, Dr. Helen.
And good evening, everyone. It's a pleasure again to be with you today, and thank you so much for joining. I thank my colleagues again to be a wonderful team that gives birth to the training, and also the participants as well as RUFORUM. This is another opportunity for us to get to know more details about R. We know that's really a powerful tool that is going to help us within our research and in the different areas of our studies, depending on the different areas of specialization. We are looking forward to have a more practical, more engaging sessions with you during the course of this particular week. And we really encourage you to be active, be more vibrant, ask as many questions as you can, and then we are ready to support you. And I'm within the Department of Statistical Methods, still at Makerere University. You're welcome. Thank you.
Thank you, Dr. Helen. I'm going to give an overview of the training, and I'm going to share something. Okay. Okay, we are going to be training in experimental design and statistical data analysis using R programming. And my three colleagues have already introduced themselves. Now we find that thorough understanding of the study design and statistical data analysis significantly enhances the capacity of postgraduate students and early career researchers to conduct high-quality research successfully. Such competence enables researchers to formulate appropriate research proposals, design scientifically sound studies, collect and analyze data rigorously, and prepare a meaningful report. However, researchers are faced with complex designs and messy data, which they cannot handle appropriately. Therefore, this training is aimed at enhancing the efficient flow of agricultural information and research, in particular to achieve the following objectives: to understand the different procedures related to design of experiments or survey schemes, to implement correctly the different statistical techniques at all stages of research, and present results in a coherent and efficient way, to strengthen the research capacity of emerging African scientists by equipping them with practical skills in R programming for data management, analysis, and presentation. The course will also enhance the quality of research outputs, support the preparation of postgraduate thesis, and promote dissemination of findings through peer-reviewed publications and policy engagement. Specifically, I would like to equip participants with knowledge and skills to download R, RStudio, R packages and install them on their computers, import their data in different formats into R, manipulate their data before doing any data analysis using interactive commands, since R supports matrix arithmetic and data structures such as vectors, to equip them with knowledge and skills to use R Markdown, where they can store the different commands, write scripts, which they can, after converting into PDF and other formats, can be imported into Word or PowerPoint. To learn different efficient techniques used in data visualization using R. To use R programming to analyze data using inferential statistical tools, such as correlation, regression analysis. We'll also look at categorical data techniques and some generalized linear models. At the end of this training, we expect that participants will be able to explain the fundamental concepts behind experimental designs and statistical data analysis, apply key concepts such as correlation, regression, categorical data analysis techniques, and generalized linear model using R. Use R programming to describe, analyze, and model the state of biological or agricultural systems in both quantitative and qualitative manner. So we expect that by the end of this course, you'll be able to handle your own data so that you are able to move from one stage of data analysis to report writing and thesis writing. So with those few summaries, I would like to invite my colleague, Dr. Helen, to take over. Thank you for listening. And before that, we sent out, hopefully I'm right, we sent out a questionnaire so that we can get some insights about data analysis using R. We want to know what knowledge you know so that we can, as we go along teaching, we can incorporate some of the ideas raised by you. In case it hasn't been passed on, we will post it in the chat or in the Q&A. Thank you for listening. And in case there is no question, I go ahead and allow Dr. Helen to continue. Thank you very much.
And thank you, Professor
Dr. Helen?
Susan. Yes. Thank you so much. I'm going to post, if you check in the chat, there is a Google Drive where we are sharing all the materials for this training from today up to Friday. So I kindly ask you that you pick it from there, and then you can try to check the materials that we'll be using. Already the materials for day one are already there. And Prof. and Thomas, you can still help me to spread it again to give it to the different participants. Thank you. Okay. Okay. All right. So as per our training still, from the expectations and the objectives that Professor Susan has presented, there's a lot of statistics that we're going to learn this week, and we want to do everything in R. So today what we are going to do, I think I'm going to use 1 hour and a half just to do an introduction to R and RStudio. And then my colleague Thomas will come in to start on the statistical modeling. So we do not mind that. I know within the group there might be some people who are well conversant with R, or we are all at different levels of understanding what R is and RStudio. But let's move on the same pace, such that at the end of the last day we are able to achieve the overall objective that has been stated. Okay. Yes, thank you. I'm seeing that the Google link is being shared. Please, that's where all these materials for day one is, and we'll keep updating it. Okay, so let's get to know about what is involved in R and what is RStudio all about, right? On this particular link that you'll see, I've put still a link where we'll be putting our materials, the one that is being shared within the chat. So you can pick it from there and then be able to have all the materials that we are going to be using. On this particular slide, for those of you that have not encountered R, or they're seeing R for the first time, and maybe some of you that have used it before, it can be a refresher for you to understand, to get to know what is really happening with R when people talk about our programming language, and then RStudio. Like different softwares in this particular case, R is also a statistical programming tool or software that somebody can use when they're doing data analysis. And what is interesting with R is that you don't need to be an R guru or a scientist to be able to use R, or you have to be a statistician, you have to know how to analyze this big data. No. So anyone can use R, and it has got interesting features that we will be seeing during the course. You can use it for data management, statistical analysis, visualization, etc. And maybe the other key thing that we need to note is that R is an open source tool, implying that anyone can use it. It doesn't need a license. All you need to know, get to internet, and we're going to see how to download it. All you need to have is that it's always good to use an updated version, because as time moves on, they keep updating R, and it's always good that you have the latest version. We'll see how do we go about that. And then the other one is about the RStudio, okay, because we're going to use the two hand in hand. Still, like R, even RStudio provides a free and open source tool. It is also free. You can still download it and install it on your computer. Sometimes it's referred to as an integrated development environment for R, because you have to integrate it with R such that you are able to use it. As we'll see, and the different features, when we open the workspace for R and RStudio, we'll be able to see different features like the console, where we can edit from, the history, the different tools for plotting, the packages that somebody needs to use, and then as well as the help space that one needs, maybe in case you're stuck and you're like, okay, where can I go? So we can also still use the help space to support us understand how can I use a given command or a certain statistical test that I'm not so sure about. And it's usually RStudio, as we are going to see, provides features to make using R and managing R much easier. Because in this particular case, we'll be able to save our scripts, the R scripts, and then within the RStudio, and we'll be able to you can come back later to use them. How are the two different? Maybe somebody might ask a question that how are the two different? Initially, we had R alone because remember I said that yes, it's a programming language used for statistical computing. And the only unique thing that you can pick from this slide is that you can use R independently of RStudio, implying that you can use it alone. But you cannot use RStudio without R. You need RStudio. You need you have to download RStudio such that you're able to use it with what? With R, implying that RStudio works along with R. And so that is really the main difference that you can keep at the back of your mind. So we need both. We need to have R on our computer as well as RStudio. And then when you download R, after that you download RStudio, RStudio will be integrated into R. Like I mentioned earlier, that it's an integrated development environment for R. Okay, so now I'm going to check in the chat and ask if because remember this is a software that we need to use, so we need to install it on our computer. We want to download and then install. We want to download and then installing both R and RStudio. When you check in the folder that we shared, the Google folder with the materials, there is already a PDF that shows the different procedures on how you can download both these softwares. But we can still look at it briefly and see how can we really go about it. Here, there are different options that you can use to download our software as well as RStudio. Sometimes it depends on the strength of the internet that you have. If the internet is very strong, then you might need like 3 to 4 minutes, okay, to download both. If your internet's a little weak, then it might take some time. But the good thing is the moment you download and you have it on your computer and then you install like any other app or software that you might need on your computer. After downloading, you get an extension file that you need to then you start following the installation procedures on your computer. Okay, but usually the easiest way, like I've put some of the things that you can follow, but we can go to the Google, and then we just put download R, and for those that do not have R, and then after that we can download RStudio. So I'm going to pause here, and then I go to Google, and I show you briefly how you can download R, and then after that, how can you download RStudio? Hopefully we can do this very fast, and then we move on. Okay, I'm sharing my screen again, and then I want us to briefly open your Google, and then we type download R. For those that have it already, there's no problem, but we have to ensure that you're using the latest version, right? And then, so in that particular case, you can overwrite already the R that you have if you don't have the latest version, and you download it manually, or you can use the different commands on updating. Okay, so when you write download R, I'm hoping that you're seeing my screen. We are having our project. If you come here, there is download R-4.5.1 for Windows. This is the latest version for R, but I know some can have earlier versions. So when you come to this particular screen, you click on download R. If you click on it, all right, it's going to bring this window, which has R-4.5.1 for Windows. Depending on the computer, for those of you that are using Mac, of course the settings might be the settings are different. So when you come here, you just read through the different procedures. Then you come to download. When I click on download, I expect R to give me to give me a download file. So when you click on it, you have to give it some little time and then check in your downloads. When you get the application, all you need is to double click on it. And sometimes a computer might ask you that, do you allow this new program to be installed on your computer? And then you can say yes. And then you can follow through the different procedures. So after that, the rest is for you to wait for the installation file, the extension file with R, and then you follow the different prompts and install on your computer. Okay, let me check in the chat and I ask if we are on the same page. Are we on the same page? Okay. Great. Wonderful. So I think that is very okay. Sylvia saying that we are downloading, and then others saying that yes, we are. That is good then. Stefan is asking, please resend the survey link also. We are going to send also the Google link again. My colleagues will share it within the chat, and then you can as well pick it from there or in the Q&A. Lo is asking, how about us who have got older versions? I'm going to show you how you can update, okay? How can you update from an older version to a newer version, okay? But you can also, like I said, you can overwrite the older version by following the same process, like the way you installed it before. If you don't want to do that, we can use, of course, it implies that you already have a hint of what R is if you have R already on your computer. So we're going to use we need to install the installer, load it, and then update R. That is the command that we shall use. Those are the commands that we shall use. But let's move on the same page. So after that, the moment you see that you've downloaded R on your computer, I'm not going to download it again. I already have it on my computer, so I don't want to install it again. The moment the download is complete, the next step is to install. Like I mentioned, when you check in the folder for the training materials, there is already a PDF that shows all these steps that I've explained to you. So in case maybe you're stuck, you can refer to it to support you. Follow step 1 to up to the last step. Okay, so now that is with the R, okay? The latest version right now we have is 4.5.1. Like the way we did it for R, it is the same way we do for RStudio. I'm showing you the easiest way, and then you'll be able to grasp the concept very easily. So now instead of downloading R, now I'm going to say download RStudio because we said we need both. Okay, so download RStudio. In case I'm fast, please alert me. Then you click enter, and then I'm going to come and click on RStudio for desktop, or you can click on download RStudio, whatever that you want, you still get it. So if you click on that, all right, I want you to scroll down. I want you to scroll down. When you come here, there are two options. Remember, we've finished installing R, all right? If you've not installed it, still here on this same page, you can get it. And then you come and click download RStudio desktop for Windows. The moment you click on it, you click on this blue button, it is still going to give you the installation file, all right? And all you need again to follow the prompts. After that, then the next thing is gonna be to launch R on your computer. Okay, let me get to the chat in case there's a question, then I see how to get about it. All right, a colleague has also shared that for those of you that are using Linux OS, like me, just use the package management tool for your system to install R. Thank you, George. That's so great. So you can as well check, George has shared something that can help somebody if you're using Linux OS. Okay. All right. I don't see any question. Patrick is saying done. Sylvia, help me with the Google Drive link. My colleagues will share it soon. Then we can, I'm going to stop sharing this and now go back to the PowerPoint. Okay. I'm going to give you 1 minute and then I ask if you're done and then we continue. It shouldn't take long. Usually within 3 to 4 minutes, you should be able to have installed everything. For those of you that are finding some hard time on how to do it, please refer to the materials in the Google link folder that we shared. Okay. Bram is saying that I'm done and I've opened it. That's great. Okay, so can we continue? What do you say about those that have R and RStudio? Please, if you already have the application installed, you don't need to do it again. Let's just wait for our colleagues and then we move on the same pace. Are we going to get a lecture recording on the Google Drive? Yeah, I think Forum is doing it for us, so they'll share the recording later. If you have R already, please, and if it's already the updated version, that is great and it's wonderful. You don't need to do anything. And then as we move on, I'll just answer somebody asked that what about in case I have older versions, what do I do? And I mentioned that you can as well re-download again, like what we've done right now, or there are certain commands that we need to use, and then you update to the latest version. Do I need payment for subscription or it's a free package? Everything is free, Edson. You don't need to pay anything. It's a free software. You just need internet, download it on your computer, and then we shall see where you need internet. And after that, you just go sit maybe somewhere and then start using the software. Okay, can I continue? Type 1. Salma is saying that everything, you can check on the Ruforum network that the recording is already on. Okay, let's continue. Great. Right. I already talked about this, you see. So now, given that, given that we have R on our computers, we want to see how do we use the R environment, working with R environment? Yes, good. I've downloaded RStudio on my computer. So what is next? Of course, we need to know how do we use it. So this is working with, so we're going to see how do we working with the R environment. I structured everything according to the concept note that we sent out. So you might be seeing some changes, but it is just for the good of us. Okay. Within the working, how do we work? Like I mentioned, so what we are going to do, we are going to go now and open RStudio. Usually when you install this application on your computer, all you need to do is that you go where there is a search button and then click R. Sometimes I personally type RStudio and then I see the app, I click on it and then it opens. So that's what I'm going to do. We just want to see how does the environment look like, and then such that all the different sessions or the training that we're going to have, remember we said we're going to be using R. So we need to know its environment. What is really involved there? Okay. So I want to share, this is the R environment. What you need to do, just go in your search button on your computer and then type RStudio. So we are launching R, and then briefly we get to learn a few important things that we need to master within the training. Remember, when it comes to these softwares, it's about practice. The more you practice, you discover new things. The more you practice, the software becomes so interactive and then easy for you to understand what is really happening. So I want to ask again in the chat, I want to find out how many of you have been able to launch your R and you're having this particular environment that I'm showing you? Okay, great. All right, let's continue. In case you have any challenge, post your question in the Q&A, and my colleagues will be happy to support in case of anything. Okay, so now this is the workspace for R. The moment you type RStudio and then you click on it, this is what you expect to see. So I'm going to just hint on a few important things that we need to use within, for the things that are commonly used when you launch R on your computer. Like I mentioned, other things you'll discover in the due course. Sometimes maybe as you're doing your analysis and then you're like, okay, how do I do this in R? And then you discover something that is really important and then you move on. Just a few things. I've gotten 4 windows. If I start with this one here, I'm having RStudio up here, and then there is a file icon. When you click on it, sometimes when you click on it, it brings a Dropbox. So there are many things that you can interact with in case you want to have an R script. When you want to write your commands, we write them in what we call the R script. So you come on new file and then you click on R script. The moment you click on it, what it will give you this blank page. and you can see that it's blinking. So it is asking you, what do you want to write there? Okay, so then that's where we're going to write our commands. And then after putting in your commands, like the way we'll see, you can be able to do what? You can be able to save your current file such that you don't lose it. Or you can, maybe if you're tired working, you can come and use it again another time. We're going to see how, one of the objectives that we are going to see today, we are going to see how you can import data. There are things to do with save all, etc. All right, that is the file. And then the other thing that, of course, this is very key, that we need to write the scripts, and then we start putting in our commands. When you move down here, we have what we call the R console. So whatever command that you write in this upper box, everything that you write, you're going to see the results executed in this bottom window. I'm just giving an example. Of course, we're going to practice. Let's assume that maybe you want to add something, like if you have, you can say like maybe 2 plus 2. That is just an arithmetic. I'm just giving, because we said within the R script, that's where we write our commands. Remember, when you write a command, you have to run it, you have to execute it. So when you run it, the results are going to be seen within the what? The R console. And it's telling you that, well, when you add 2 plus 2, you come up with 4. All the results will be seen down here. When we run different statistical tests, like the way we're going to see them throughout the course of this week, all the results will be seen within the R console. And then from there, we shall learn the interpretation of results. Most of the time, when you create an R script, the moment you start writing in it, the script will give you, it will tell you that whatever that you've written here is not saved, it will turn red. So if you want to save it, all you need is to come and click this icon here. All right, when you click on it, and then your information will be saved, and then you can direct R where you want to save it from. When you move on the right, there are also two, on the right here, we have what we call the environment. Remember, we're going to see, how do I bring data, depending from wherever I want to get it from. Is it from SPSS? Is it an Excel? Is it from different types of data from other softwares can be imported within R. So if you import your data successfully, you'll be able to see it here within the environment. Of course, if you've done some work, you will see the history, that these are the things that you've done, and then someone might be interested in the tutorials. The tutorials can support you also to do, for example, personal reading and understand the different basics, or to give you a startup on where you can. When you come to this downer window, on my right below the window, we have also some other interesting icons that we can pick. We have the plot. We are going to see how to do different plottings. All right. As the different facilitators share the different segments, you might see that the plot will always pop up in this particular window. R uses different packages. So in case you want to install a package, or if you want to update a package, you can come here and you can click on install. And then after clicking there, they will ask you, okay, what package do you want to use? You write the package name and then you click install. We're going to see that as we move on. We're also going to see the help space, the one I was talking about. If there's something that you want help on, we'll see the different commands that we use, and then the help will pop up in this particular window, etc. Basically, those are some of the key things that can support you to understand the workspace of our environment. And then later, like I said, as you practice, you discover different things. Okay, so I'm going to stop here and then go back to the PowerPoint, unless if there is a question. Okay. So I've explained this. That is the R environment that we shall use. And now let's move on to some participants were asking, how about me who has got an older version? What do I do? Okay, you can update both R and then RStudio, all right? So I've already shared the first option, like you can download and install a newer version of R, like the procedure that we went through. The way you installed R initially, you can follow similar steps and then you overwrite the version that you have. Option number 2, we can use, because you're saying that how can you update? I have this feeling that you already have an idea of the R language that you can use. So there we use the installer package. The installer it's install and then you put R at the end. So that is the package that we use. So after installing this package, you have to load it because R needs to know what to work with. And then you have to load the library, which has the function that we need to use to update R. And that is the update R. So you just need, it is only one command that you need to use, provided you have installed the package and you've loaded it. And so the command is update R. So you can you can open any script within the R environment, and then your command number 1 you can install, load it, and then update R. Initially, when you see this here, the screenshot, I was using 4.5.0 R, the R version. And then most of the time when you launch your RStudio, it will tell you that, you know what, there is a newer version of R for you to download. Would you like to continue? So, I mean, as you get to those shots, you keep reading, and then after that, so this is how you get to that there's a newer version apart from what I'm using, and then you can go ahead and download. You can also update the RStudio. All right, if you're using an older version, and the moment you update it, you expect to see something like this, that you are using the newest version of RStudio. Okay, let me pause here and see if there is a question. I think we are good to go. And somebody's course is asking that, can you try with us so that we can follow how to update? Okay. All right. So let me stop sharing, and then I share the R script. I share the RStudio here. Okay, so now what we are going to do, we want to support those participants that already have R, but they want to update. Like I mentioned, you have a little bit of what a package, you want you know what a package is. And you know, for you to use a given package, you have to install it. And then later, you load it as a library, because when you're loading, you're instructing R, that there are some functions I need within that package that I want to use. So, and there are many options of how you can install a package. Like I mentioned, I'll put the easiest. If you don't want to write install packages, you can come here, like I mentioned, and then you click install. All right, there is that option. So you need to write install packages, okay? And then there you write install R. That is the package that we use, all right? And then that is our package. I hope you're following. And then the next one is we have to load it by using library installer that. I'm not going to install it on my computer because it's already installed. So what I'm going to do, I'm going to just click the line number 3, the library. But in case it is not installed on yours, please do so. I'm going to click run. Okay, so after that, remember we said we use update R. Okay, when you come here on update R, all you need to do after that command, you click run. When you click run, you see that when you come to the console, there's this red button. So you need to give it some time and then to check and see. Now what it is telling me, I don't know if you're seeing the short, that no need to update. You are using the latest R version 4.5.1. That is what is happening to my end. Let me check in the chat if it's okay with you. Eric, yeah, you can update both. You can update both R and then RStudio. And each time you ask if you're using the latest version, it will tell you that you're using the latest version of R or you're using the newest version of RStudio. Philip, do you have, you're saying that it shows the R GUI with only one environment, R console. Did you download both R and then RStudio? You need to have both of them. Otherwise, if you don't, that's what you'll have. You'll only have only one workspace. The moment you install R, make sure you also have RStudio. That's how you solve that, because we said RStudio is an integrated environment for R. Okay, those are the questions that I've seen in the chat, and unless if there are more, please, you can post them in the Q&A. For those that had an older version, have you managed to update? Have you managed to update R? Please type 2 if it has worked at your end. Walter, if you have it already, you don't need to. And still, if this is a disclaimer, if you don't want to update right now, you can as well try later. But this one does not stop you from engaging in the session. For now, we can use the older version, maybe at night or later after today's training. When you happen to have free time, you can do it. So we can use the older one, All right, sorry, the older ones as well. And then when you happen to have free time, you can you can update to a newer version. Yes, somebody is asking about losing old packages. Yes, within the installation period, they'll ask you if you wanna continue with the older packages, you can say yes. But in case the R asks you to install them, then it is easy for you. You just install and then now load them and continue with your work. Prince is saying that sometimes error come due to network, the system cuts the process off. Balu Wycliffe is saying I'll update later. Great. Okay, let's continue. We can update later. Let's use the versions that we have for now. There is no harm. Okay. If you have an error that could not find the function update R, it implies that you have not installed the package correctly. Because that particular you need to alert R that within this particular library, I'm going to pick this. That's update R. It's a function within our installer package. I'm giving you a minute and then I continue. Okay. Thank you. George has shared some insights within the chat. You can also read about them and then we can continue. All right. So going back to the PowerPoint. Okay. Like I mentioned, we can update later. You don't need actually, like you have to do it now. No, you can do it later. We can use the version that you have. The other thing that we want to do, it's about, after learning about the R environment, we can move on to do some basic commands, right? Now, you need to open an R script and then we do some basic commands. I mean, just getting inquisitive with what is really happening. All right. You can do arithmetic which includes addition, division, etc. You can assign values. All right. There are also some inbuilt functions that R already has that you can use. And then we're also going to see you might be working on something, but you're not so sure, like, maybe I want to compute the mean of A, B, C, and D, but I need some help on what is the command, all right? Because R is command driven. And the moment you understand these commands, that is all that you need. And then you can reproduce the different commands from one research project to another. Okay, so I'm going to first explain this briefly, then we go to R. We also what we call data structures, and these ones you can look at it in terms of vectors. We know that a vector, these are just ordered collection of elements. So you can create a vector. For example, remember we talked about maybe briefly. Let me first go back and explain the part of assigning values. You can say that my x can be my variable. If you don't want to refer to it as x, you can call it maybe age. You can give it any name, okay? When within R, when we are assigning variables, we use this particular assignment, less dash. You keep seeing it within the different sessions. So less dash is an assignment operator, okay? But in case you don't want to use the less dash, you can as well use the equal sign. Still R will what? R will accept that. So you assign and you're like, okay, my X variable is 5, my Y is 10. The moment you assign a variable, okay, it is stored within the environment, the R environment. And so you can do different computations that you are interested in when, because the information is already stored. Like we will see, and you're like, maybe I've said X is 5, and then Y is 10, and you can say X plus Y. It will give you the what? The results. With certain functions, like I say, now this is a command. If you want to find a square root, the square root of what? These are inbuilt functions. And you're like, I want to get a square root of 16. All these commands are typed within the R script, and then we see the results in the R console. And then min is also an inbuilt function or command. And then you're like, you want to have a min of min bracket, and then inside we are seeing there is a C1, 2, 3. C implies to concatenate, that put everything together. So what I'm saying that C inside 1, 2, 3, what is the min of 1, 2, 3? So you're asking R, and then R will give you the answer. When you come to the help command, you can put a question mark, and then question mark of what? You can ask yourself that I want to know more about the min. If you don't put a question mark, you can type help, and then in bracket you put what? You put the min. Okay, and then I'm going to explain briefly about this, and then I go back to R. We're talking about vectors, all right? You can create different data structures in form of vectors, in form of tables, etc., data frames, as we shall see. So, like I said, V less or dash, I created an assignment operate my variable V that it has 1, 2, 3. That is the vector that I created. All right. I also created another one which I called names. Okay, and I'm like names less dash, this then C. Within my names I have Anna, Ben, and then Kate. Sometimes when you have these vectors, you might want to access different elements, and you're like, okay, maybe your data is very big, and then you're like, but I want to pick element, maybe an element within the 4th row or in the 3rd position, etc. So if you write V, then close brackets 2, you're telling R that give me the value within the 2nd position, and so it will give you the 2nd element. Some other things that you can look about, maybe length is also an inbuilt command of your vector. What is the length of V? Which V I already have up here, and then maybe you want to sum or you want to sort. Like I mentioned, you cannot understand all these things at a go, but if you have your data set, basing on the objective that you'll have, they will guide you. The objectives will guide you on what exactly that you need to use. And then lastly, on data structures, before I move to R, is this particular, is this one here, which we can look at data structures in form of data frames. All right, especially in this case, we are looking at when you've gotten a data set, what do we do? With these ones, they are table-like, for example, like you go to the field and then you collect your data. These days we've got different ways of how you can collect data, and automatically you can download it immediately, depending on the software that you're using. But most of them, you see, they're in Excel form structure. You have the rows and then the columns, whereby rows, they give you the different entries that you have, and then the columns, most of the time they have got the data variables. So I'm looking at my DF, that is, I'm looking at it as the name of my variable. So data frame is a command. I want to create, look at it as a table or as an Excel. That is the simple word I can give you. And then you're like, within my data set, I have the name variable. I want, there is Anna, Ben, Kate. I want the age variable. I want the score. There is also the score variable. Remember my names, they're just 3 names. Then I have the age for the 3 people, and then the scores, all right? So still within this small data set, I can do a few things. I can be able to come up with, okay, in case I want to get only the age, all right? R also has a $sign that you can use when you want to pick any variable within a data set. All right. For example, you put the name of your data set, $age. This is what this command does. And then maybe you want to pick also if you want to pick a given row within a given data set, you put the name of your data set, then you put closed brackets like the ones here. But since now this one is a data set, remember there are rows and columns. The first are the rows, and then the second is the what? The column. So here with this command, just this one here, you're telling R that give me the first column and all the entries within the row. Then when you come here, it's now I've just changed, instead of having the row, I put in the column. That give me all the entries within the first row that belong to the second column. So whatever you're seeing here, I'd also put how it looks like within R. So now, before I continue to a new concept, the last concept, I want us to move to R, and then there is a script that's within the folder which has basics in R, and we open that script and we follow through briefly. Okay. Any question before I continue? Any question? Okay. We continue. We see just briefly how to do what I've talked about in R. Colin is asking, what is nesting? Nesting in what terms? Putting things together? Maybe you can clarify more in the Q&A such that the question is clear, but it's not clear to me. Where did I get the commands? Within the folder, please check. There is an R script that has basics in R. Those are the commands that we are going to follow. But in case you're also interested to rewrite everything within an R script, that will be very good, because at the end of the day, as you practice, you tend to understand things very fast. Where did I get the commands? With the commands, we write them, all right? R is command driven, provided you install the right packages. and then you write the commands like the way I'm going to keep explaining. Why are names in double quotes? Okay, Junior, why are names in double quotes? Remember, they are strings. It's a word. So when you put double quotes, you're telling R that this is a word that I'm referring to, which is different from when we're writing, for example, 1, 2, 3, when you're putting numbers. With numbers, we don't put double quotes, but if you're writing a statement, even if like you want to write a sentence, for R, for it to look at it as a string or a statement, you have to put double quotes. That's a good question. And how do we change the file repository away from the one already shared with the R script? What we can do in that particular case, Ernest, we can open a new R script. Okay? So how do we open a new R script such that instead of you can rewrite now everything on your own, all right? There is this icon here which has it's like a white paper with a plus, a green plus. Okay, you can click on it. Then you after clicking on it, it is going to bring a drop down, and then you click R script. You can have as many scripts as you can. It doesn't matter whether 5, whether 10 or what. Okay, and then you work independently. Or if you don't want to do that, like I mentioned, you can go to File, New File, and then you create an R script. So whatever commands that we want, then we start practicing. All right. Okay, let me check again. I think I've answered Mohammed about that particular step. I'm hoping that is clear. Does R also index elements from 0 when accessing them like some of other programming languages? Yes, it does. So it can as well also index the different elements. Okay. Let's continue. So within the basics in R script that I shared, all right? These are the things that I was talking about within the PowerPoints. But what I'm just doing here is that I came now and wrote them within the what? Within the R script. If you don't want to use the basics in R script, you can as well open a new script or a new file and then rewrite everything. You can as well still do it later, or we can move along. For example, I mentioned that within the basic commands, we can do addition. So all you need to do is go to, it will always pop. It brings a pop, and then you're like, okay, like I wrote earlier here, like 2 plus 2, and then you click run. If you click run, it will give you just a second. Yes, I was opening the basics in R again. When you have 2 plus 2, so when you run, like we mentioned, maybe it's something that I might have skipped. sometimes you might need to put some notes within the R script such that you're able to remember what you are doing, okay? So how do we do that? You write whatever that you want, and then before it, we put what we call a hash or a ladder, this one here. So for it means comment. It's just a comment, but it's not a command. Like it can support you to, maybe as you're executing different commands, you can put notes for yourself, all right? So, and then you're like, initially, I just wrote basic commands because I don't want R to look at it as a command. It is just a statement that I wrote, and then I put a what? A hash, such that at the end of the day, R looks at it as it's just a comment. It's not something that I want to execute within R. So whatever we do up here, when you run R, you see the results within the R console. Okay, so and then after it pops on the next line and so on. When this was just division, you run that, and then the other one was just the power, and then you see the results down here within the R console. Okay. Now, the other part that I was talking about of assigning variables, that you can say my variable x can be anything, that I assign it. This is an assignment operator within R, that it's 5, okay? I put semicolon, like I can write, you can write different things, different commands on one line, but you can separate them with a what? A semicolon. If you don't want that, you can as well put it on different lines, okay? And then I say my y is equal to 10. So if I run that line number 7, I'll see that within the environment, x equal to 5, it is being stored. When you look on your right, the upper window. And then if I say my y is equal to 10, it is also going to be stored within the environment. So the moment it's stored, it implies that you can manipulate now whatever that you want to do. You can say x plus y, and then now it will pick whatever it is being stored, and then it will give you the answer. That, okay, x was 5, y was 10, and then it will give you 15. When you come to the functions, you can use most of the time when you're writing a command, like in this particular case, the square root, these are inbuilt functions that are already there. So you put whatever it is, you want a square root of what? So you put it within the what? Within the bracket. So I said for 16, and then you run it. If you run it, you see the results below. All right. We also said that, even min is a command, min of what, and then you click the run, and then it will give you the answer. I talked about the help command in case maybe there's something that is not clear, that you want to really understand more in details. You can always use the help command. And how do we, in that particular case, you write question mark, then you put of what? What do you want to inquire about? Okay, I want to inquire more about the mean. If you don't put a question mark, you can, instead of a question mark, you can use command help, right? Help. And then inside help, you want help on what? And then within the bracket, you write it there. So either way, whether you put a question mark, whether you write the help command, the results are it will give you the same thing. So if I run line 15, okay, and I can't remember, I talked about the help space. All right. So when you come here, it will tell you that arithmetic mean, it will give you it always gives you the description, the usage, and then from the usage, as it tells you, okay, the command will be mean of x blah blah, and put some other arguments. But as you read further, all these arguments are being explained what they do. All right, sometimes it gives you references. It also suggests some other topics that might be of help, that are in line with what you're asking, and also it gives you examples. Okay, so after trying to understand what is within the help space, then you can easily refer back to your work. Okay, great. So you can say help on the t-test, and then it will give you results. We can try that and we see. What about in case I say, give me help on a t-test, all right? When you run that, you have to check within the help space. It gives you different things. It first tells you what it is, okay? And then after that, how do you use the test that you're asking about? From that, it explains to you all that is within the test, what you need to know. As you continue further, it gives you more details. Like I mentioned, sometimes it gives you other things related to what you're asking, the different examples. And then we believe that after going through this, then you can be able to refer to your own work, etc., anything that you can think about. All right, and now let's move on to data structures. Like I mentioned here, I picked a variable v. V can be anything. You can change it to G, you can change it to whatever that you want. R is case sensitive. You have to maintain whether it's capital V or small v. So I said I'm assigning my V to B1, 2, 3. C is to concatenate. I don't know whether a colleague is what was asking about, like putting things together, or that is the nesting. I'm not so sure of the question. And then with the names, still we put C in bracket, like there is Anna, there is Ben, there is Kate. So when you run this, these are just vectors, the ones that I mentioned. When I run line 20, I run line 21. Everything is being stored within the environment. So if I say V close bracket 2, I'm telling R that give me the second element. Okay, when I run that command and I check it, will give me 2 because 2 is within the second position. If I come to now, I use the variable name, then close bracket of what? Of what position do I want? Then in case I put names now, 3, I expect to come up with the third element.
Excuse me, Ellen.
Yes.
Yeah, let the participant type in the Q&A.
Okay.
Yeah, because we cannot respond to everyone in the chat. Somehow the setting need to be changed.
Oh. All right. Participants, please, in case you have any question, type it in the Q&A, and then you'll be responded to. Thank you. Okay. So as we continue, all right, then when you come to line 23, like I mentioned, you can re-record them on your own and to see that you're able to follow very well. It's always good to practice. So if I run line 23, it will tell me that within position 3, there is a name called Kate. Then there are some others. You can get the length of what? Of V. That was my, because, and then the sum of V, then the sort of V. Whatever that I want, I put it in there. Okay, now the last part before we get back to the PowerPoints, we talked about looking at this one is mostly going to be used when you're having your data set, practical data set. We call them data frames, but I mean, the simple language is a data set. But within R, I'm like, okay, I'm going to call DF, which is a data set. The name that I've proposed, that I'm calling my data set, DF. You can call it Helen, you can call it any name that you want. All right, it's not that it's a constant, you have to maintain DF, no. This is just something, it's just an assignment. Then I'm using this because I want to create a data set of my own. But we are also going to see, how about in case you have your other data set where you collected your data, how do we bring it in R? It's also something very important, but the concept remains the same. All right, so the command is df. I can say data frame. This is the command that we use, data frame. Okay, I want to create a data set. Inside my data set, remember I've got brackets here. So I'm saying that inside, I want to create 3 variables. I want to create name, which is equal to within the name column. Okay, then I want to have the 3 names. Within age, I've got the ages of the different names as well as the score. Okay, in case I have more data set, in case I have more variables, all I need to do is to put a comma and then I type another variable. Maybe age, then score. I can say, okay, I'm interested in gender, just giving an example. You can say, and you can, like I mentioned, you can put an equal sign or you can put a less dash. And then you say, see, I'm concatenating. I know Anna is a female. Since it's a word, I can put if. I can say female. All right. Then I put comma, Ben. This one is a male. I say put comma, then Kate. And I say Kate is a what? A female. All right. If I have more, I keep adding. I'm just creating how a data set can look like. So if I run, remember this open bracket, the closing is down here. Inside the open bracket, I've put this. This is what I want to see. Okay. Now, if I run that line, this command runs from line 31 up to the close of what? The bracket. So if I run this, when I look in my environment, it tells me that this is data, which you've given a name DF. I'm explaining this. It has got 3 observations of 4 variables. Remember, these observations are the rows, implying that we have 3 entries, okay? And then the 4 variables, these are within my columns. But maybe I want to see, how does this data set look like, which I'm calling a data frame. So I only write the DF. I only write the name that I proposed. So I come and I write it after, and then I run. Now, you see that when I come now down to within the R console, I'm able to see the names, their respective age, the score, and then the gender. This is what we usually see when we collect data, the entries and the rows and then the columns. And what I have up here, these are the variable names. it is something that I've just created, but we can use our own data set. So how about in case these are the basics, like that, the way it is at basics in R, but later we build from the basics, they are going to support us to build more on what we are going to be doing, and then becomes very easy. So what about in case I want to access like age only within this DF dataset? I said you write the name of the dataset. If you want to pick a specific variable, you use a $sign. And then after the $sign, you put what variable do you want to see only. So there, I run this line, and it will only give me only the age. That within the age, I have 23, 25, then 30. I can do it with the rest of others. It's the same thing, DF, and then I can also say, I want to see only the scores. Okay, and then I run that, and it will also give me the same. Now, what about maybe I've got this data set and I want a specific row. All right, this is the command that I'm going to use, that go within my data set, which I named DF. Okay, I put close brackets, the row, and all other entities in the what? In the column. So when I run this is what I see. It gives me the first row and the rest of the entries within the column. So it is telling me the first one is Anna. He has an age of 23 with score of 90, and she's a female. All right. One within the DF, if you see that it's a 1 and then comma. It's usually row by column. All right. When you come to this second one, still you're telling R that, you know what, go and within a DF, within my data set, which I named DF, give me all the entries, okay? Give me all the entries in the column, in the row that belong to the second column. So this should be the age. When I run that line, that's what it gives me. It is the age, it is the second one. Age has 23, 25, and then 30. There's also some other commands that we are going to see as we move on within R. And these are also commonly used as you're doing the analysis. So you don't need to worry and you're like, okay, but the commands are very many. What am I going to do? Do I need like to cram them? You don't need to. With practice, after some time, you're going to get to know that, okay, if I want to do A, B, C, and D, this is what I need, period. Okay. So there is a command which is str. That is the structure of the data set. You want to see what is the data type of your data set. So the command is str, which implies structure. But we're going to see more details on this as we move on. And then inside, you want to see a full structure of how your data set looks like. All right, it will tell you that how the different variables are. So in case I run line 46, all right, it will tell you that, you know what, your DF data set, it's a data frame. Of course, it will tell you 3 observations of 4 variables. And then this side, it gives you the name. So it is saying that these are characters, okay? There is Anna, Ben, and then Kate. And then it is seeing age score as numericals. They're just numbers, all right? And then we have gender. It is also seeing it as a character because they are wordings. But most of the time, as we're going to see that in the analysis, the moment it is a categorical variable, I hope we all know what categorical variables is. You need to tell R that, okay, no, basing on gender, it's categorical in the sense that we have two labels, a female and then a what? And then male, such that R changes from calling it a character to a factor. How do we do that? Just briefly, the command is very simple. What we do, you say df, my data set, then $, I'm calling gender, okay? I want to assign less dash, or you can say equal to. The command we use to tell R that this variable is categorical, we use as dot factor. Like I mentioned, there are different ways or different possibilities on how you can do something. Somebody else, maybe those are well versed with R, can use something else, and it is still okay, provided you communicate to R what exactly that you want. So I'm going to put everything there, and then as a factor. So when I run this, all right, I see it within the console. Now I want to run the structure again. It is now telling me, yes, the rest are okay. Now gender, instead of looking at it as a character, that they are wordings, now it is a factor with two levels, female and male. Okay, we can also get a summary, the basic statistics, some of the basic things that we can do. Summary of what? I want a summary of my data set. And then I click run, and it is going to give me this. Of course, yes, I know that then with the variable name, they are just names. I don't need to do anything there. When we come to age, it gives us some summary statistics. Remember, it's numerical in nature. The same applies to score. And then it tells us that when you come to gender, we have 2 females and only one male. This is just a hint, but we can apply these same commands to a bigger data set. And then this other last one, which is head df, it's usually most of the time when you want to check to see how your variable. Yes, please.
Dr. Helen?
Yeah.
Can you please inform participants to send the questionnaire online? They should not send it to any email address. They just reply and submit on the Google link so that they are received in one go, not in the email, because the emails will fill up.
You shared the link?
It needs assessment.
Yeah, the link was shared.
Okay.
Yes.
Share.
Let me also share the link again.
Okay, great. We are sharing the Google link with the trainees assessment. Please use the Google link, the Google form. Sorry. Don't use the Word document, because with that we can easily capture the responses and quickly do the analysis, and we can inform you back in time. Yes, it has been shared. Just copy it and then you can use it later. Maybe after the training, and then please share with us your responses. It takes like 3 to 4 minutes. It's not really long. You can't see the link because you're posting also. Okay. All right. Prof, can you share it again? Please stop posting and then you can copy the link.
I'm going to put it in the Q&A because in the webinar, cannot post anything to them. It only goes to hosts and panelists. So I'm putting it in Q&A. Is that clear?
Yeah, but you can check to everyone. There is a drop down there. And then you change the setting to everyone.
Helen, we can't have everyone on webinar chat. That option is only for them, not for us.
They need to change.
So I think the person will rectify that tomorrow. But for today, we are using the Q&A. Yeah.
But they
And
can
I'm
still pick it from.
posting. They can still pick it from Q&A.
Let one of them pick it and put it in
Let one of them pick and put in the
chat.
in the chat.
Okay, okay, great.
Thank you.
Thank you too. I think they have done so. Okay, please pick the Google form link, and then you'll take some time and just respond to the few questions that are there. Doesn't take long. We need your response, and then we'll share later what the results will be. Somebody saying submitted. Okay, so fast. All right, thank you. I have only 19 minutes to end to give my colleagues. So let me ask, can we, do you have any question? I hope the questions have been posted in the Q&A. If there is something that is not clear, put all the questions there, and then you'll get the response that you want. I want to look.
Dr. Helen.
Yes, please.
Dr. Helen, somebody is saying that RStudio does not install on computer. That RStudio does not install on their computer. I don't know what type of computer he has. Maybe he can share, or he can tell us the operating system of the computer. There's a question in Q&A.
Okay. But that person needs to be promoted, or be promoted and then ask, or he can write what kind of computer he's using with or she in the chat, and then we find out how we can help. Prof. Susan, what do you think? That's what I'm suggesting.
Yeah, let him indicate the operating system of the computer. Then we can help.
Okay, all right. Okay. Many people are saying submitted, done. That's great. We encourage everyone to do so. It will be good at our end. Why is our environment is empty while using R have something already? Please put the questions in the Q&A, because by the time I read and then I want to answer it, the question has disappeared. But the answer is very simple there.
Helen?
Yes, please.
Some people want to know how to transform a given data, and I think they also want practice. So maybe you create some few minutes for them to practice what they've already learned.
Okay.
She can go on. I should not restrict because you're saying 19. She can go on. Maybe because now if you don't finish what she wants, then what will we do?
That you go on and finish what you're supposed to do.
Okay.
Okay.
Just only one concept that I want to do, and then I'll be done. It's about the last bit on the introduction. It's importing data. So let me ask in the chat, is it okay if I move on? Can you type 1? We continue. We look at only the last concept, and then we end the first session. Okay. Please remember to fill the Google form with the link that has been shared. It only takes just like 3 minutes. You are done. Thank you all that have responded. And then we can continue. Okay, somebody is saying that you were explaining head DF. Okay, let me explain that. And then I do the last concept and I stop there. The head is a command. Okay. Head itself is a command. As we move on, during the analysis of your data, you will need certain commands. You'll get to know that, okay, I'm doing this kind of analysis, so this is the command that I need, all right? So head usually, by default, it gives you the first 5 rows of your data set. It's like you're checking. You want to really confirm, like, is what I'm doing, am I really using the right data set? And these are some of the checkups that you can do to support you to confirm, like, okay, yes, maybe you want to be sure of the different variables that you're considering. And so you can type DF. So remember, with our data set, it only has only three entries or 3 observations. So when you run DF, it will bring everything. But let's assume that you've got maybe 100 observations. What it will do, it will only bring only the first 5. If you want to see the last 5, then you type tail DF, okay? It will give you the last 5 what? The last 5 entries. I'm just giving you a minute, and then I'm going to look at importing. Okay. Let's continue with the last concept we want to cover within the introduction. And then I believe that you would have learned something. When we are importing data, we're going to see how do we do it in R. So most of the time, you can import data. Maybe data has been saved as a CSV, or it has been saved as an Excel. Those are the common ones, okay? I'm looking at most of the common file extensions that we tend to have. But apart from the CSV and the Excel document, you can also import data from other softwares. It is not limited to only the CSV and the Excel document. So, like we mentioned, that R is command driven. In case we are importing, all right, files or a data set from your computer, if you saved it with an extension of CSV, then we use the read.csv command. Okay? If you saved your file as an Excel file, the command that we will use, it is read_Excel. These are just the commands that I'm talking about. Like here it is read.csv, and then inside we put the name of our file. When we are importing files, when you want to read files within the Excel document, within the Excel that have been saved in Excel, we shall need the read Excel package. How do we get that package? You install it. You use the library to, after the moment you install, we load it with library. We are telling R that the command that I'm going to use, it has a function within this library. So, and then, so the command is read underscore Excel. In bracket, we put our what? We put our file name. This file could be anything. Maybe you saved your file as agriculture, or you saved it as employment, or you saved it as soil. That doesn't matter. Okay, but we have to put that real name. I've already talked about that. Then if you name, in this case, I consider data as the name of that is the name I want to use in R, that I'm calling the file or the data that I'm importing within R as data. That is the name that I want to use. So when you come, for example, head, I want the head inside data. I've already explained that. We can as well view, maybe you want to see the whole of your data set. All right, that's what you usually have. And then here this is the same thing. Here I use data. Here I just change the name to employee. The same command. Then now in this case, my file name is employee. I can explore most of the things, like, and I can use the head employee, then summary. I can as well access a given column. So these are the different procedures. All right, we're going to use option 1. I'll illustrate that. When option 1 is usually, most of the time we use it when we are importing Excel files. Okay, we're going to see that. And then within option 2, if you have a file that is saved as with an extension of a CSV, we first set a working directory. Okay, to tell R that within this folder, that is where my file is, or the data that I want to import is. So is important. So within R, we go to session, set working directory, choose directory, and then you select the folder that contains your data set. Within the material folder that we sent, there is an employee.csv and then also employee Excel file. But I would also encourage you to use your personal data in case you have it on your computer. You can import that, not necessarily what I sent. Okay. Any question before we move to R to see how this is done? Please post the question in the Q&A. Is it possible to share the power presentation slides? All the materials that we are using are within the Google link. So we are not going to share the PowerPoints. You have to have that link and then access all the materials, because we keep updating it on a daily basis. Okay, I'm going to stop sharing, and then I share R, and then we continue and we end. Still, I'm using my file, the script basics in R. All right. When you check in the folder that I sent, there are two types of data sets. It's an employee data set, all right? But within that, then there is one that is saved as Excel, and then another one has a CSV. So we're going to first start, I'm going to first start by showing you how you can import the one with Excel extension, the XLXS. So how do we go about that? You go to File, okay. Then you can do Import Dataset. Then import dataset, we can say from Excel. Like I mentioned, you can also have data from SPSS, from SAS, from Stata, and then you import it in what? In R. But for now, let's say from Excel. So if I click on that, this is what you're seeing is it was going to bring a window. All right. So you go to Browse, and then you have to check where did you save that data. I would encourage you to download that folder where there is this content and you put it on your computer. Mine, I go to my folder, then I check employee.xlsx. It's what it's the data that I'm importing. The moment you import it correctly, it is going to give you a preview of the data that you want to import. Okay, how it looks like within the Excel. To tell you that it has a gender, years in school, job category, current salary, like how it looks like within the Excel. So when you come down here, it gives you a code preview that in this particular case, the library we are using, it is readxl. And it has used the name of the dataset that I saved employee as my default name. This is the command, read_excel, all right? And then inside is the path that I used to get to where this Excel file is. Then there is another command, which is view employee. This one just supports you to see how the dataset looks like. And then from there, I click import. The moment you click import, this is what we see. Okay. This is what it shows that, okay, the data that we've imported, this is how it looks like. Like the ID number, like maybe you went to the field and you have your data within Excel, right? So this is how your data looks like with the variable names on top, and then within the column name, those are the variable names, and then other entries that have been collected on each participant, basing on their ID numbers. When you also come and look at within the environment, it will tell you that you have the employee, that is the data set, with 474 observations of 9 variables. So we have 474 observations. These are the number of participants, and then the 9 variables, where there is gender, years in school, job category, current salary, etc. All right. Okay. So the moment you've imported data, then the rest is it's just doing the computation that you want within R. You do some basic statistics in case you're interested, or there are some questions that you want to answer according to your research, and then you go ahead and answer them. But want to understand now only is how to import data. Other bits about, yes, I've brought in the data now. What do I do next? We are going to see that in the different sessions that we'll receive on the respective days. I don't know if that is fine. Okay. Is that okay? Great. All right, let's continue. Now I'm going to do the last bit. Here we're importing data that is saved in Excel. All right. How about when our data is saved as a CSV? The main objective we want to achieve here is data importation. The bits later, we'll see them in the due course from the different facilitators when we import, and then we do whatever we want, the computations that we want. Okay, so how about, I'm gonna close that. How about in case your data, I want now to use the same data when it is saved as a CSV, saved as a CSV. Here, we need to first create a working directory. Of course, like I mentioned, there are different procedures on how you can import data. It's not that what I'm telling you is the final thing. Maybe some of you have got other ways that you can use, but I'm just trying to show you some of the different ways on how you can import data. How can you bring data from wherever it is into R? There are different approaches, but I'm showing you some of the simple ways on how you can do it. If you've got a better way, that is great, wonderful. Learning is continuous. So what we do, we want to tell R that my data, now I want to import data that is being saved as a CSV. So how do I do that? I have to set a working directory. Okay, the working directory, it's the one that shows the path where my data is. And remember, we have different computers. So what is expected is that we've got the working directory have to be different. Maybe somebody saved the data on a desktop, or somebody saved it in the My Documents, or somewhere else. All right. So I don't expect us to have something uniform. Okay, so how do we set the working directory? So in that case, you come to session. Okay, you click set working directory. Then you come to choose directory. What we are trying to do here, you want to tell R that my data is found within a given data set. Okay, so my data is saved in a training data set, in a training R folder, which is on the desktop. So the moment I reach that folder, then I click open. So when I come here, it is just, I'm navigating the path that, okay, this is where you can find my data. You go from the users, come to the desktop, then at the desktop, you go into the training _R folder. That's where my data is. So after that, we use the read.csv command. Okay, the read.csv command, it is the one that is going to support us to import our data that is saved as a CSV. So it is read.csv. This is the command that we use, read.csv. It implies that I can read now my data that is saved as that with an extension of a CSV. All right. When you check in the folder, all the data sets are there that we sent. It has got the employee.csv, and then the other one has employee.xlxs with the one over Excel. So when I come to this particular line, I assign that I want to call my data set employee. Remember, this name employee, it's the one that I've used, like the way I use the DF. okay? But you can change it to anything that you want. It doesn't matter. It's not that it's constant. It has to be like that. And then now inside here, I put the name of my data set, which is employee.csv. And I put everything into what? Into double quotes. So when I click this, when I run line 63, I come and check again within my environment to show me that it has been imported successfully, that employee has 474 observations of 9 variables. And then from there, the moment you've successfully imported your data, the next thing to do is to do the analysis that you're interested in. All right. How, in this particular case, how do I view my data in case I want to see how my data looks like? You can come and click on this Excel icon. If you click on the Excel icon, then it is going to show you how your data looks like, just for you to see a quick look to check that the data that you have, it is really what you wanted to import. All right. Like if you are successful on that, and then now you can go ahead and employ different commands that you want to use. Within the same, we've already talked about the summary command. So in this particular case, if you have summary as my command, then within the bracket, I just need to put the name of my data set. Remember, in this case, I've already mentioned up earlier that I'm calling this data set employee. So summary employee, when I come and click on it, I can run it and see, okay, does it really concur with what I want to do? For example, you see here that gender, it is telling us that it has 474 observation and it's a character. So here you can be able to see that no, now I need to convert, because when I collected my data, gender had both female and males. So I have to use as a factor to convert gender. The same applies to job category. Job category had different levels. Okay, it's not a character. I need to convert it to a factor. And then the last bit is about minority. We are looking at a data set for employees which had, they're collecting different experiences from people. And minority, whether it was also category, asking whether one was a minor and then 0, not a minor. So that's why when you come to line 69, I wrote convert characters to factor. And how do we do that? Like the way I've already explained, we use as a factor command. So as if when I use I need to convert gender, I need to convert job category, I need to convert minority. These are variables that I have. So I can run these lines. I can run all that line. Of course, there's also a command that can convert all the categorical variables automatically. But since we are exploring, we can learn more. And then I can run the summary command again and see what it is showing me. Now it is showing me that in gender, the females are 216 and then the male is 258. When I come to the job cut, it has clerical, custodial, and then the managers with their respective frequencies. And then the minority, those who belong to 0, they are 370, 370, and then 1, they are 104. These are just frequencies, all right? And then with the numerical ones, the numbers, of course, what do we expect? Summary statistics, mean, the minimum, the mean, and then the maximum. Of course, here it gives you the minimum, the first quantile, median, mean, third quantile, and then maximum. It all depends on how you want to report your data. All right, how you want to report your data, and then you pick only the elements that are what? That are important. I'm gonna pause here because that's what we wanted to do is wanted to achieve is to see how do we import data. So let me ask a question. Are there some people that have been successful in importing data? Okay. Yes, I'm seeing a lot of the yes and ones. That is wonderful because importing data is key. It's where everything starts from. If you're successful in importing your data, then from there you can be able to do the rest of the analysis. Okay, great. Yes, please.
Somebody says you could not import CSV file. So maybe you can just go to that line and show them.
Okay.
CSV.
Thank you. Thank you, Prof. You need to first ask yourself, have you gotten the right working directory? That is the first question you have to ask yourself. You have to know where is your folder where you have stored this data set. Is it in My Documents? Is it on the desktop? Or you saved it somewhere else? I would advise that you download these files and you install them on your computer. All right? For mine, the folder where this dataset, employee.csv dataset is, it is called training_R. So you also have to check where is that training, where is that folder which has this dataset. You have to check that inside that folder, it has the employee.csv. I remember we saved it with the date for today. So as you navigate, as you're setting the working directory, in the end, instead of having training_R, it should have today's date. I think that's where the problem is coming from, because that path has to be correct. The moment your set working directory is right, okay, then we use the read.csv command. And inside the read.csv command, we put the name of our dataset. So I've called the name of my dataset employee. This is the assignment name that I've chosen. And then the read.csv, this is the employee.csv. This is the name of the dataset that I saved with my data. So if I have that, first you have to check your set working directory if it is right. Then we use this command, and then you run that line 63. It should then you should be in position to see that within your console you have no error, implying that now you're good to go to do the analysis. If it is not clear, maybe you can share and we can support you. Thank you. I'm going to hand over back to Prof. That's what I had to share today with the introduction to R and RStudio. Thank you so much. Over to you, Prof.
Okay, thank you very much, Dr. Helen. I think we need to give him a thank you in the chat and the Q&A. Please, participants, go ahead and thank Helen for the great work done to introduce you to R. I believe now the rest of the sessions are going to be easy because we have a foundation of how to use R. Now I go ahead and invite Dr. Thomas Odom to handle statistical models. Do you need a break? Should we give you a break of 10 minutes? Let's have a break of 10 minutes. That means we come back at 4:25. A break, get a break. We'll be back at 4:25 Ugandan time. We'll be back at 4:25 so that you can now get ready for the new session. So please have a break. You can go off and come back at 4:25. We'll start with another session. Thank you very much. Helen, is all the material in the Google Drive? And data set? Helen, are you there? Dr. Helen? Oh, where has she gone? Dr. Helen, do you have all the, you can actually upload it now, before. Hi, Daisy Salif, how are you? Can you, she can't unmute. But I can't write to her. Okay, yes. Hi, Daisy. Use Q&A. Somebody else is replying, hi. did Daisy get to know? You've shared it?
Wait, I'm going to share.
Or you can send on my email.
I want to. Let me share. We send it on. You can download it there.
On no Q&A.
Now share
And,
the one that is the chat, because you'll get it.
Webinar. Oh, I have a visitor, and for us we had cooked peanut sauce. Now I have to go and buy chicken.
Hello, good afternoon, everyone. Am I clear to everyone? Can I see the chat if you're here listening to me clearly? Okay. Okay, thank you. So what I'm going to do now is we are going to just get an overview of statistical modeling, and then we are going to provide some kind of roadmap on how to select which model to use for your study. So we're just going to set some criteria so that tomorrow when we start doing analysis, you know exactly why a certain analysis is selected for a given set of data. So what is a statistical model? So the simplest thing here, I know. So a statistical model is simply a structured way to describe how that called the systematic pattern, the pattern, and then okay. So if for example we have yield data, I mean it can be any kind of data that you collected. You want to explain the variation that you observe in the yield data, and you think part of the variation is, and part of the is due to the water that you've applied to the plant. But there's always that component that is you cannot explain, and that part that you cannot explain is always what we call a random variation or random noise. So you can see in the language of statistical modeling, this crop yield here is what is called the response. In some cases called the output, in some cases called a dependent variable. So this is mainly the variable that you want to explain. And then you have on this side, you have what called the predictors, or you have explanatory variable, or you have the input. So the water and the fertilizer here, you're trying to use them to explain the variation in the yield of the crop that you say you have vested in your experiment. Or maybe you're interested in studying the household income, and you want to see what are the factors that are responsible for the outcome what factors influence your household income. So there are two components here. We have what called the systematic pattern, and then we have what called the random noise or the residual effect. Anything else that you cannot explain become what we call the residual effect. And this is very critical in the sense that this is used in the testing itself. So when you're doing a testing, we are looking at the pattern divided by the noise. That ratio there will be able to tell us whether there is something going on or not. When you come to the statistical model, we're always interested in looking at, we have what we call the parameters of the model. So here, for example, you can have what we call the beta naught. Then you have the effect of the fertilizer being represented by B1. And then you have the effect of the water being presented by beta 2. So when you're doing your statistical modeling, we are interested in estimating this. We want to estimate this. You want to estimate that. You want to estimate that. And then you also want to know what is now that variation. That is that thing that we cannot explain. So when we are talking about statistical modeling, the interest is mainly interested in the relationship between what we call a dependent variable or response variable or output with the predictors or explanatory variable or input. And so the process of statistical modeling will first of all involve identifying the different variables that you have and which ones are the response variables and which ones are the predictors or which ones are the explanatory variable, and then choosing appropriate model and then estimating the different parameters of the model. So the thing is that there are several models that you are supposed to choose for your own data analysis. So each model comes with some kind of assumptions. So assumptions here are simply conditions about the data or error that must hold true for the model to work. So here, the assumption could be related to the error term itself, or it could be related to what you have here, or related to this relationship that you have there. Okay, so every statistical model rests on certain assumptions. So if the assumptions are okay, then it makes the analysis to be valid, and the conclusions that you're going to draw will be something that is trustworthy. Otherwise, then your result, you may be excited about your results, but there may be issues to do with validity of your results. So what happens if you violate those assumptions? So if you violate those assumptions, you're likely to end up with biased estimates. So we talk about these estimates here. So we talked about these estimates. We need to estimate this. We need to estimate these values here. So if the assumptions are not correct, the values of the parameters that we are going to come up with are going to be far away from the actual or the true value. And then any kind of inference that you're going to come up with is likely to be wrong. And you certainly don't want to come up with wrong inference after doing all the studies or spending all the money. There are some assumptions. In most cases, what happens is that we start with the assumptions of what called the general linear model. So this is the most common one that we always use. So now if the assumptions of these models are violated, then you're going to look for other types of model. So we are going to, within the week, we are going to look at a number of assumptions. The first assumption is related to what called linearity. So we are saying that the relationship between the two variables that you're trying to read to test, two or more variables that you're trying to, it should have a straight line relationship. The next is what called the independence. So here we assume that the different observation that you've collected are independent of each other. So let's say, for example, you have 10 data points, and you assume that each data point is independent of the other. And then, of course, what we know is that in most of our introduction to statistics courses, we talk about a normal distribution. And here, the assumption is that the residual, which we saw, is supposed to be normally distributed for us to assume that a linear model assumption is okay. And then there's what we call homoscedasticity, which is simply we are saying that the variances of the error terms are supposed to be constant. It's not supposed to vary. And we are going to see this in the course of the 5 days or the 4 remaining days. And then and then am I clear, or saying is the audio is low? Okay. So here we have what we call the multicollinearity. So this is mainly related to what we have as the predictors. We don't want them to be very related, to be highly correlated. If they're highly correlated, that means they are supplying the same amount of information, and in one or the other, it may not. It may have an issue. We make our model not to function properly. So these are some of the assumptions that we are going to look at within the next 4 days. I already talked about why it's important that the assumptions are not violated. So the first thing is we want to have validity of inference. So this ensures that the p-values or the confidence interval that we are going to come up with are accurate. It is also going to ensure that the results make sense scientifically. Because remember, at the end of the day, you're going to write a thesis or you're going to write a paper. So you don't want to pick analysis that is questionable, so that whatever comes out of the results out of the analysis is also going to be questionable. And then you also want to be able to generalize your study to a wider beyond the sample that you use. Now, if the assumptions are violated, then you're likely to have issues with validity, how the results are interpreted, and then how you can do the generalization. So let's say, for example, you want to compare the walking speed of men and women. Now, if you go and decide to say, well, I'm going to pick the women that I'm going to select are going to be very tall women. The men that I'm going to select as the men that I'm going to select are going to be very short men. So in that case, your results may actually only be only apply to that particular sample. If you try now to take your result outside the study, you're likely to have issues because the sample that was picked does not have certain characteristics that you have. So somebody already asking the level of multicollinearity that is tolerable. I think we are starting to walk. I think we should not start running for now. Let's wait for at least keep some questions as we move on. I'm just giving an overview so that once we start coming in, we are going to move. We're going to cover most of these things. There's still people saying my audio is not loud. Others are saying is okay. I don't know. Okay. So what happens if the assumptions are violated? So the first thing is that you always need to do diagnostics. So in most cases, it's going to be based on what we call our residual plots. And then you check whether there's violation of any assumptions. So I already talked about assumptions of linearity. If it is violated, the estimate that we're going to end up with is going to be biased. For independent assumptions, we are likely to underestimate the standard error. For non-normality, we are likely to have a test that is invalid, especially if you have a sample size that is smaller. Remember, for large sample, always we can assume normal distribution without having challenges. And then, of course, the issue of constant variance, if it is violated, then we are likely to have inefficient estimates, or we're going to have wrong standard error. So this is just a general guide. And as we move along the week, we will bring all these assumptions back and we're going to discuss them. So what happens when assumptions are violated? So the first thing is, what do we do when there is violation? So there is what we call data transformation. I know a number of you have heard about transformation. So what you do in this case, for example, instead of, let's say we are looking at maybe household income. So instead of analyzing household income, we could, for example, analyze maybe the log of household income. And with that, we should be able to at least try to sort out some issues of assumptions that were violated before. So you can have a log, you can have a square root, you can have arcsign, or any of the other transformation that is available to you. We may talk about transformation briefly at some point along the week. The other thing is that instead of insisting on using a certain model, you could change to models that will handle a more general, the model that can actually handle violation. So for example, you can use what we call generalized linear models. So this is where models like logistic regression or like Poisson regression models, instead of using the general linear regressions. We can also use what we call the linear mixed models under certain violations, or we can use a generalized linear mixed model. Or in some cases, you can also use a non-parametric method. So as I indicated before, this is just going to be a guide. This is something that we are going to be using from time to time. So the whole idea is that if you picked a model, you need to check for the assumptions of that model. So if the model is correct, the assumptions are not violated, then you're going to come up with trustworthy conclusions. So the idea would always be you can fit a model first, check whether the assumptions are not violated. If the assumptions are violated, you can either do data transformation, or you can pick another model, and then once you're satisfied, you can go ahead and do the interpretation. So it is always that you don't fit a model. In some cases, what will happen is that there are people, sorry. Okay, so the thing is, you don't just fit a model and then stop there. So at the end of the day, what you need to do is, after fitting the model, you also need to check whether the assumptions of the data meets the assumptions of the model, after which then you can go ahead and do your interpretation. Okay, so that is generally about what a model is, and then what are the assumptions of a model. So now what we're going to do now is we're going to guide you a little bit on how to choose a model. And we're going to list the criteria that you can use to decide which model will be good for you. Okay, so as we have already seen in the assumptions that the choice of your model will affect the validity of inference, the interpretation, the recommendation, and the decision making that will come out of your work. So remember, if you're going to spend lots of money to collect data from the field, so if you don't do the right analysis, all the data that you collected will totally be wasted. The most common mistake that is always made is that we first look for a model that is familiar, a model that we know, or we look for some cool model, and then you don't think about, is it suitable for my data or not? That one you think you'll get sorted out along with time. So here, as I indicated, we are going to provide a roadmap for model selection. So the first thing is, you must have a research objective. I know if you're a student or you're a researcher, you always have research objectives. You have research questions, you have research hypotheses, and this should help you to select an appropriate model. Okay, so a model should be, your model is a tool to answer specific questions. Okay, so you don't start by choosing the model and then look for a question that it can answer. So in most cases, say, oh, I'm going to use a linear model. That is what I'm going to do. It doesn't matter what, whatever my objective says, that is not an issue. So for you to have to really choose the right model, you need to have a good background knowledge of the subject that you intend to study or you intend to model. So that means if you're a biologist, your biology should be very, very good because you have a certain relationship that that you're interested in studying, and that relationship should make sense biologically. You may have a model that fits the data perfectly well, but then biologically it may actually that it may not make any sense at all. So your knowledge of the subject matter is very critical for you to choose the correct model. So these are some key questions that can guide in your model selection. The first thing is, what is the precise relationship or the phenomena that I want to study? What kind of relationship do I want to study? The second one is, what is the outcome variable of interest? Am I interested in, is my interest in crop yield? Is it in adoption of a technology? Is it in household income? So you need to identify that outcome variable. So if we go back to what we define as what a model is, the key thing here is we need to look at your outcome, this side of the model. We need to know if you're interested in studying crop yield, which is maybe in kilograms of ton per acre, that is going to be different from somebody who is interested in whether a farmer has adopted technology or not. So the nature of the outcome of the study will determine the type of model that you will choose. And then the other thing is also, what are the key variables, key explanatory variable that you have? So remember, we look at this, that you have your yield data. You have, this is your intercept. Then maybe we want to have the fertilizer effect. You want to have the water effect and any other explanatory variables. So as much as we know the outcome, we also need to understand this explanatory variable. Their nature, how they behave, is likely to determine the choice of the model that you're going to choose. The other thing is also how is the data distributed? What are the assumptions of the model? Remember, we talked about the model assumptions. So every model comes with its own sets of assumptions about the data. So you cannot force a certain model on a certain type of data. The model that is used for studying relationship between, say, weight gain and let's say the amount of feed given to piglet, for example, is different from the model that you use to study to understand adoption of a given technology. So there are going to be assumptions that you need to take into consideration. And then, so the nature of these variables and the relationship between them will determine the choices of your model. So we are going to look at the different types of model depending on the types of the variables and assumptions and so on and so forth. Are we together? Can I see in the chat? Type 1 if we are together. Okay, good. This is, okay, we can continue. Okay, so the first one is the relationship that you're interested in studying. So we always advise, it's highly advisable that before you start doing any data analysis, it's important to try to have a graphical representation of the relationship of the variables that are of interest to you, because that will guide you in the choice of the different models. So let's say, for example, if your data behaves like this is what we call a quadratic. This is what we call a cubic. You have an exponential, you have a logarithmic relationship. You also have here there is positive linear relationship, negative linear relationship. So what we always do is you can just have a simple scatter plot. So you'll notice from the next 2 days that before we go into any analysis, the first thing that we always do is to first do some summary statistics, including having some graphs that will actually be able to, will inform us of the choices of the model. So let's say, for example, we have a situation where the Y, your response has only value of 0 or 1. So you can see from here that these are the ones with the ones, and these are the ones with the zeros. Of course, you can try to force a linear relationship to go in between them. Or you can look at another model that does not, it's not linear. Like here, for example, you can do a logistic regression. So this is, for example, where you have the relationship between the variable that you're studying. In this case, is you're trying to model probability. So a probability is bounded between 0 and 1. So if you have a linear regression, for example, you may end up with values that are above 0 and values that are above 1, below 0 and above values that are above 1, and which will certainly not fit. So in that case, then you will be interested in using things like logistic regression. So you always start with a simple data visualization, which can tell you whether you have a linear relationship or a nonlinear relationship, but can also tell you, for example, that you have data that is censored. So for example, here you can see that there's no value between -5 and +5. Now, this could be because of some reason. You may have a machine, for example, that does not measure above a certain level. So all the measurement above, say, 100 will all be taken as 100. So in that case, you have some kind of truncation. And in that, you may need to choose a different model compared to, say, you have a situation where all the measurements can be done. Okay, so the first thing is the nature of relationship or the phenomenon that you want to study. So this one here, you can do simple data visualization that can help you to know the kind of relationship. But we also assume that being a scientist, either you're a biologist or you are a social scientist or you're an economist, you have a rough idea of relationship that you're trying to study. If you're studying relationship between demand and supply, you know how that relationship behaves, and that should help you to choose a suitable model. Now, the next criteria is about our response variable or our dependent variable. So the type of variable is going to be very key. So if, for example, you have a continuous variable, like things like crop yield, income, weight, gain. Now, this will have a certain sets of models acceptable for them. If you have binary, yes or no, or dead or alive. If you're an entomologist, for example, you spray insects with insecticide, your response can either be whether the insect is dead or alive. So that's just 2 categories. You may also have more than 2 categories, like multinomial. So let's say, for example, you have 5 different technologies. And the farmer can pick any of the 5 technologies. So in this case, you have instead of having yes or no, you have yes or no for each of the technology. So that one can be handled in a different way. There are cases also when your response is count, like those ones. Maybe you're interested in the number of insects trapped in a trap somewhere. You may be interested in the number of patients visiting a clinic. You may be interested in the number of farmers doing a certain thing. And then we have what called the censored or truncated data. So this is, for example, when you only know the upper limit or you know the lower limit. Let's say you are interested in studying relationship between let's say maybe amount of rainfall and the number of people who pay to go and watch a particular a football match in a certain stadium. Now the stadium will have a maximum capacity, so it doesn't really matter whether the weather is good or not. Once the capacity is full, capacity is full. But then, so you can see that we have an upper bound in that particular case. So that will affect the way you're going to analyze or to model that kind of data. And then there's also what called time to event. So maybe you're interested in time until a farmer adopts a certain technology. So what we are going to do now is for each of these types of variable, we are going to mention the type of model that you can select. And based on that, that would be the first criteria that you can actually do. Then after selecting the model, you try it on the data, you do the model, the assumptions. Once you check the assumptions, you will decide whether you continue with that model or whether you need to do data transformation or whether you want to look for another model. So for continuous dependent variable, so the first line of the first choice is always the linear models. So the linear models makes a certain group of assumptions. So analysis as simple as a t-test is an example of a linear model. If you do analysis of variance, that is a linear model. If you do analysis of covariance, that is a linear model. If you do regression analysis, that is also a linear model. But whether you're going to choose ANOVA, you're going to choose a regression analysis, will also depend on the nature of the explanatory variable that you have. Okay. If the assumptions of the linear models are violated, you could opt for a linear mixed model, which relaxes certain assumptions, or you can go for a non-linear models, which would then require that you don't need the linearity, or you can do it if you can do a data transformation here so that you can use the linear model. So this is, for example, this is when you have a continuous dependent variable. So mainly like crop yield, prices, income, value, something that you can measure on a continuous scale. So your first target would be a linear models. If the linear model fails, you may go for a linear mixed model or a non-linear non-linear models, or there are many other models out there that you can have. Now, if you have a binary dependent variables, where we have the yes or no category, so here the main is you can use what called logistic regression, which is a logit model, or you can use a probit model. So a probit model mainly used by economists. Logit regressions are used a lot widely by social scientists and even biological scientists. So the idea here is that the response here is either a 1 or a 0. If you try to fit a normal linear regression, you may actually get an estimate that is outside the range. So you can get a probability that's negative, you can get a probability that is positive. But if you use a logistic regression, then it is bounded at 0 and bounded at 1. So all your estimate will fall between 0 and 1. The other one is if you have more than 2 categories. So let's say you have 3 varieties. A farmer can choose either one of them, or you have choices on where to market your produce. You can use a rural market, urban market, or a regional market. So these are the models that you can use. There is what called multinomial logic model. This is similar to logistic regression, but only now that in this case we have more than 2 categories. You can also use a multinomial probit, or if the responses are ordered, then you can use ordered multinomial logis or the probit model. So this being used a lot in economics, and this one used a lot in other social science and maybe in the natural sciences. Remember, the choice of the model sometimes also based on simple thing like where you studied, where you want to, which field you are. You find maybe animal scientists prefer to use a certain model, maybe crop scientists prefer to use a certain model without really having any particular reason. And then if we are dealing with counts, so let's say the number, if you have a set of technologies that you're going to give out there to the farmers and you count maybe the number of farmers who adopt, number of farmers who are adopted, number of technology adopted by a certain farm, okay, or per farm, the number of pest outbreak. So here we have mainly two categorization. We have what we call the Poisson regression or negative binomial regression. But when there are lots of zeros, then you may need to go for the zero inflated Poisson regressions, and then you have the zero inflated negative binomial regression. So these are mainly when you have count data. Let me check if there are some questions. Yeah, the guides on logistic regression is we are going to talk about those. So you shouldn't worry. This we are just giving an overview. We also have, I think I'm about to finish. We also have what called censored or truncated dependent variable. So this is where your values are constrained within a certain range. But the underlying process is continuous. So you could have a situation where the values are constrained between these. Okay, but then the process that generates could also have this. So sometimes it may be that maybe the machine just doesn't record what is up here, so you can restrain like that. I mean, when you look at the sensitivity of certain machine, they may not measure below a certain amount. So let's say you have a scale that weighs maybe 0.0. I mean, let's say it has 0.5 grams as the minimum. So anything below 0.5 grams now can be categorized either as 0 or as 0.5. And then you can also have that for above. So this is where mainly the model that I use for censored or truncated dependent variable, unless the censoring is from time for survival analysis, then you have what called the model 1, model 2, and model 3. The good news is that most of these informations are now widely available online, so you can always go and start looking at what's the difference between Tobin model 1 and Tobin model 2 and 3 and so on and so forth. But I'm just trying to say that Tobin model 1 is used when the dependent variable is censored at a known threshold. So sometimes maybe at 0, but we believe that the underlying latent process is a continuous process. So you can look at Tobin model 1 and Tobin model 2. And then we have what we call the time to event or duration. This is very common in medicine, for example. So you may be interested in time until a farmer adopts certain technology, or time until a disease sign shows up or appears on a crop or on a plant. So this is mainly handled using the survival analysis, especially the hazard model. So if you're dealing with a case where, let's say, you're monitoring a group of farmers, and it can reach a point that before the farmer adopts a technology, the farmer drops out of your study. So that can also be under survival analysis, but it's also kind of a truncation that you'll actually have there. And then there's also the issue of data structure. Now, if those who do survey, for example, if you can do what we call a cross-sectional study. So a cross-sectional study would be you're doing a one-time study. you go to a group of, or I mean, you go to a village and you select a group of people, they answer your questionnaire, and that is it. This is different from what we call a longitudinal study, where you start from a group of people, like what's done in cohort studies in medicine. So you can start with a group of people when they are young, you follow them up until when they become adults. So a lot of these studies was done like in tobacco, for example, to try to get relationship between smoking and say lung cancer. So what would happen would then that you pick a group of people, of smokers and non-smokers, and then you follow them over a period of time. So the data from cross-sectional study will be modeled differently from the data from longitudinal studies. So for cross-sectional study here, you capture information at a single point in time. And in most cases, what we can do here, we just look at association between variables at a single point in time. So you cannot control for anything that you don't observe, especially things that changes a lot with time. So the model that you select in this case needs to be controlled for what we call endogeneity. So, or if you want to claim a causal relationship, then you may need to be a little bit more cautious, because remember, you're not controlling very many things as you have. So you need to know whether your study is cross-sectional or if your study is longitudinal. And then in plant, crop, or animal, you can also do repeated measure. So repeated measure means I can have a plant, I have my plant, I tag this plant. Once I tag this plant, I can start taking measurement first week, second week, third week, and so on and so forth. So here you capture information, the same subject repeatedly over time. And this is extremely important when you're looking at changes, you're looking at trend, and then you're looking at cause-effect relationship. Most of the studies that relate, let's say, tobacco to cancer, lung cancer, for example, most of them were longitudinal studies that took place over a long period of time. So this is, if you want to really have a good cause-effect relationship, apart from doing an experiment, then you need to do a longitudinal study. So the model that I use here includes the linear mixed model. If you assume that if you're dealing with continuous variable, we talk about continuous variables, or you can do a generalized linear mixed model if you're looking at a non-normal variable, or you can also do what called generalizing estimating equation. So mainly if you are interested in the population average versus individual subjects average. I think this should be among the last one. I know we are supposed to stop at, according to the time, we're supposed to be 5:30, but we're going to end before that. Now, when you're dealing with time series data, this is also very common. Then you need to take into consideration what we call autocorrelation. So autocorrelation is simply, in this case, remember the assumptions of, say, those who use analysis of variance. The assumption is that the error are independent of each other, or the observations are independent of each other. But in time series or repeated measures, there is going to be a relationship between observations that are close together in time. So let's say, for example, I take observation on my plant week 1. I take it in week 2. I go to week 3. Now you can see here that week 1 and week 2 will be more related compared to, say, so week 1 and week 2 will be more related. Maybe week 1 and week 3 will be less related. So here, for example, we can see that maybe if you are the points that are very close together have a high correlation. As you move away from a particular point, the correlation reduces up to a certain point when there is no correlation. So this is, you can have a positive error you have a positive error being followed by a positive error, or a negative error being followed by a negative error. So like what we have in this particular case. And then the other thing that we take into consideration is what we call the non-stationarity. So statistical properties of the data set, such as the mean, the variances, tend to change over time. That also needs to be taken into consideration when you're handling time series. So in that case, the model that you can use for time series analysis are also different. They're mainly, you use what we call the ARIMA model. We have what we call the VAR model, the vector autoregression model. We have the co-integration analysis, then we have the Gauss model. I'm not going to go into the detail for this, but at least what we are trying to do in this case is we're trying to give you a menu that you can actually use to help you make your own choices. And then we can still, maybe you ask the forum to organize another meeting. We could go deeper into some of the models, because remember, we have just 5 days and only 3 hours per day. So there's nothing much we can do. And then for those who are doing geographical studies, we also have spatial models. You have like the spatial lag models, you have the spatial error models, then you have geographical weighted regression models. So that means if you are a geographer and you're dealing with points that are correlated in space, then you need to take care of what we call the spatial autocorrelation. Compared to the time series autocorrelation. So they are similar, but you're handling them in a slightly different way. So the other thing would be whether are you interested in prediction or forecasting, or you're interested in getting an explanation. Because these days, if you are interested in just prediction only, you're not interested in explaining, then you can do machine learning. With machine learning, then it can go into the data set and get for you the best prediction possible. But if you are interested in causal relationship, then you need to take into consideration things like the endogeneity that we're talking about, what we talked about. And then, so this is where you have a situation where you're looking at a relationship between X and Y, but then there are also other variables that also influence that relationship. So the error term itself, it still has some signal. And because it has some signal, there will be a correlation between X and the error term. That means you cannot explain that. So if, for example, you get if let's say something happened, a crime took place, and there are 10 witnesses. Now, if you only use one witness, that one witness may not be able to capture all the information, may not be able to give all the evidence that is required for the case to be prosecuted to the final point. So there are other angles that the other nine witnesses could produce. This is also the same. If I'm interested in crop yield and fertilizer, or the amount of nitrogen in the soil, but remember, crop yield is also influenced by many other variables. So if those variables are not taken into consideration, then you're going to end up with a relationship that is actually not correct. So we have what we call omitted variable bias. So there are things like maybe soil quality. You're interested in studying relation between yield and fertilizer, but you also need to take into consideration things like soil quality. But you could also have a situation in economics, for example, you know that we say the demand and supply. Let's say Y is the supply and X is the demand. But you see that the law is that if there's actually a reverse causality at some point. So in that case, then you can use what we call the simultaneous equation models. That can help in a situation where there is what we call reverse causality. Okay, so here, let me just go to some practical consideration. In the past, the computer used to be a limiting factor. So you can estimate the model with your available. So you need to ask yourself whether the computer that you have currently is able to do the job. I can see that some of you are struggling with putting R on the computer. Maybe you're using a computer that is fairly old. So you need to be able to ask yourself the complexity of the model. So some spatial or maximum likelihood models are very computationally intensive. So you may need to borrow somebody's computer, or at least go to your computer lab or go to your computer unit in order that you pick a computer that has the power or has the ability to actually do the work that you want. The other thing is also interpretability, especially when things like transformation comes in. If you want to explain your results to, say, policymakers, sometimes you don't want to go to a very complicated model. So a simple, ordinarily square model may be easier to explain than if you go for some complex Bayesian hierarchical model. It may do a good job, but then at the end of the day, you want to see is the complexity worth the extra effort? There is what we call parsimony. If you have two models that seems to explain something in a very similar way, then you go for the simplest one, because that makes life a lot easier. The other thing is also what is there in literature. So sometimes you find that in a particular field, there are models that are preferred. Probit and logit model do the same thing. The results are very, very similar. But maybe an agriculture economist will always use a probit model. And you ask them for, but it's just maybe the precedent that has been set up by some people sometimes back. So so you need also to look at what is acceptable, but what is also quite rigorous enough. And finally, these are some checklists in modeling. So the first thing is you need to define the questions. So you need what is your X and what is your Y. Then you need to define what's the type of your Y. Is it continuous? Is it binary? Is it a count? This one at least can narrow down. Do we have a cross-sectional? Do we have a pan? Do we have a time series? Data, hierarchical data. Then the other thing is issue of causality. Do you need to make a causal claim? If yes, you must address the endogeneity. But if you're not interested in the causal, then you can go and use your machine learning. You can check for special features. Do you have a spatial data? Are there selection issues? So this will add another layer of complexity. Then you can always run. We are going to see, we'll run and we test and we see exactly what is going on. So you estimate the model and test the assumptions. If they are violated, then you can choose a different model, or you can do your data transformation, and then you redo and you check again. And after that, you can interpret, you can validate. So I think that is what we had prepared for this first day. This is just to give you an overview of the modeling process, how you make your choices. And these days is, you're a bit lucky in that if you know what you want, it's easy to get around. So sometimes the thing is that people don't know what they want, and that's where the problem comes in. So we can have some questions maybe, but I think we can end here for today unless there's some very serious questions that we have here. So the links are shared. We share the link, and this link will be updated from time to time. So all the new material will be put into what has been included, and then you add on to what you already have with you. Okay. Yeah, so I think in the interest of time, maybe my colleague has anything to say. Okay, so I hand you over to my colleague, Susan, and then she can hand you over to the forum team, to Selma. Yeah, thank you.
Minimize yours. Thank you very much, Dr. Thomas. I would like also to thank the participants for being patient with us. Tomorrow we will start same time. The link will be shared in your emails. There's not much to say. I hand you over to Reforum. Any representative of Reforum who is available?
Yes, Prof.
Is she there?
Thank you very much, Prof. Can you hear me?
Selma, are you around?
Prof, are you
can
hearing
take
me?
over.
We can hear you. Please proceed.
The slides will be shared in the Google link. That Google link is open. Even after the training, it will be available for you to download the information. So they will be shared. And the YouTube also has recording. Okay, I think there's nobody of Reforum online.
Selma is there. Prof.
Let's call it
Hello?
a day. Thank you so much. We meet tomorrow.
Prof. Selma is
And
there.
have a
She will
great
close.
evening.
Selma,
Bye-bye.
Selma,
It's
please
like they are not
close.
hearing me.
Okay.
That's the challenge I have.
I'm going
Can you hear me?
to log off for everybody.
Jolene, are you
Bye.
hearing me?
I can hear you. Please close and lock off everybody.
My professor is not hearing me and she's already ending the meeting. So,
It's okay.
colleagues, thank you very much. I'll see you tomorrow.